am Sura Ngenzi. I'll be taking you through this lecture on curriculum development and evaluation. We will deal with section 3, which is actually part 4 of our course material, statistics and evaluation in education. The concept of statistics. Statistics is the science of collecting, summarizing, and analyzing data obtained from the tests, experiments, surveys, questionnaires, and interviews. This definition is according to Bennett and Census 2071. It is also defined as the science of collecting, summarizing, and interpreting data. Teachers work with the students' data obtained for evaluation, for example, from tests and examinations, thus making statistics very important in education. What is evaluation then? Evaluation refers to value judgment or valuing. Also, it means measuring progress towards set goals or objectives. Various scholars define evaluation in different ways. Kindly visit this site at your own time for further reference. What to evaluate? We can evaluate teaching and learning progress. We can evaluate programs. We can also evaluate curriculum, etc. Importance of statistics in education. We use statistics in education to describe the data or observations, to condense or summarize information, to draw conclusions about the properties of the population under study. It helps a teacher to interpret scores. It helps us to compute various statistics and interpret statistical results. Branches of statistics. We have two branches of statistics, namely descriptive statistics and information statistics. Descriptive statistics. This is a branch of statistics that deals with description, classification, and presentation of data by using various statistical methods, such as means, ratios, proportions, or pictorial, such as tables and graphs. That is, data are described either numerically or pictorially. For example, when you calculate measures of central tendency, such as mean, average, mode, and median. Also, calculating measures of dispersion or variability, such as range, variance, and standard deviation. Also, drawing graphs, such as bar graphs, histograms, pie charts, or give frequency polygon to represent frequency distribution. Note that number 1 and 2 above indicate numerical representation of data, while number 3 indicates pictorial representations of data. In other words, descriptive statistics is defined as a science of describing data. As seen above, when we talk of statistics, we have data in mind. For example, summarizing data, describe data, compute various statistics from the given data, interpret statistical results, draw conclusion about the population under study. Data can be ungrouped or grouped. What is a statistic? A statistic is a calculated, estimated, or derived numerical value or quantity. For example, mean, median, standard deviation, etc., which represents or describes the characteristics of a sample. As we know, ultimately a sample represents the characteristics of a population under study. Let's have a look at the following example of a given data of students' scores. Before that, let us have a look at levels or scales of measurement. When we are talking of data, all data has been divided into 4 levels or scales of measurement. Scale of measurement show the rules used to assign a particular number. There are 4 scales of measurement, namely nominal, ordinal, interval, and ratio scales. Nominal scale. Under this scale, a variable is classified by some quality or attribute or categories. Numbers are used to distinguish one group from another. This scale is characterized by unordered categories. That is, there is no ordering. For example, when we talk of gender, we have 2 categories. We have male and female. We can use numbers here to assign a male. For example, we can say 1 is for male, 2 is for female. The numbers has no any attribute of ordering. Also, you can use, for example, 1 for Christian, 2 for Muslim. The numbers have no sense of ordering. We also have colors. You can use numbers to represent various colors. Again, there are no ordering in numbers. They simply represent categories. Number 2 is ordinal scale. Under this scale, variables or data or observations are put in order from the lowest to the highest, or from the highest to the lowest, but there is no constant interval between them. Data are ranked. Examples are student scores when ranked from the first to the last, or from the last to the first. Socioeconomic status, for example, we can say high socioeconomic status, moderate, and low. When you are taking the alphabets, there is a sense of ordering. Also, administrative positions at the school level. For example, we have a head teacher, deputy head teacher, senior teachers, and teachers. You can see some sense of ordering there. Interval scale. The data of all variables in this scale have the following characteristics. Numbers or variables are ordered. There is constant interval size between 2 successive units. That is, when distance or difference between one interval and another is known. This is really its distinguishing characteristic. Another characteristic, the 0 point and unit of measurement are arbitrary. That is, 0. It has no true 0. For example, when you say 0 degrees centigrade, it doesn't mean that there is no temperature. Only that the temperature reads 0 degrees centigrade, but the temperature is there. Therefore, ratio or measurement does not have meaning. You can do addition and subtraction. Examples are temperatures, as I have already said. Ratio scale. It possesses the characteristics of the other 3 already mentioned scales. Data are ordered. Constant interval. There is constant interval between 2 successive units. It also has a meaningful 0 point as its origin. That is, it has a true 0 point. This again is the distinguishing characteristic of this scale. You can make some addition, subtraction, multiplication, and division. Examples of ratio scales are measures of length and or weight. When you are talking of weight, you can have 0 grams. When you are talking of length, you can have 0 length. And from there you move to 1, 2, etc. Frequency distribution and graphical data presentation. As seen previously, one of the importance of statistics is to summarize data of test score, is to summarize data. Let us look at the following data of scores of Form 2 biology test of about 40 students. As you can see the numbers, 24, 36, and lastly you have 72 there. These are raw scores. The data above can be summarized in a frequency distribution by first ordering the scores from the lowest to the highest, or from the highest to the lowest, as shown in Table 2.1 when you refer to your course material. As you can see from your reference, after ordering it, the table is still long and detailed. It fails to summarize data effectively. So the data can further be summarized by using class intervals, and that making a grouped data. This is more user-friendly. Measures of central tendency. Measures of central tendency are measures of centeredness of the data. The goal of these measures is to describe a group of scores with a single measurement. Measures of central tendency sometimes are called measures of location. Commonly used measures of central tendency are mean, mode, and median. As you can see, when you are talking of the mean, you are talking the majority of the people who appear at the center. So centeredness is reflected there. We have ungrouped data and grouped data, as you saw in previous discussion. Calculations are done based on whether the data is grouped or ungrouped. We shall consider calculations of ungrouped data of the mean when discussing measures also. We shall consider calculations of ungrouped data for the mean and other measures. The mean. This is the average of the scores, or is the center number. For our case, we are going to deal with arithmetic mean or average. However, in statistics, we have the population mean, which is represented by the letter mu, and sample mean, which is represented by a symbol X bar. Mean of ungrouped data. Example 1. Find the mean of the following marks: 60, 45, and 40. Solution to this: to solve this problem, you have to use the formula for the mean. The formula for the mean is summation of the variables which you have been given, which are represented by x. You divide by the number of observations. For our case, we take 60 plus 45 plus 40 divided by 3. Our n is 3. You have 145 over 3, which is 48.3. Therefore, the mean of the given data is 48.3. Mode of ungrouped data. The mode of ungrouped data refers to the most frequently occurring score in a distribution. For example, consider the following scores. You have 2, 6, 8, 6, 9, 9, 10, 9. As you can have a look, 9 appears 3 times. So the mode is 9 because it occurs more often than any other scores. That is, it has the highest frequency. The median of ungrouped data. Median of ungrouped data is given by the middle value when the scores are arranged in either ascending or descending order. When calculating the median of ungrouped data, 2 things must be put in consideration. When the total number of observations or scores is in a distribution is an odd number, for example 3, 5, 7, 11, etc., here the median is the middle value when the scores are ordered. For example, you have 3, 5, 8, 10, and 11. For this case, the total number of observation is equal to 5, which is an odd number. Therefore, the median is the middle value, i.e. 8, with 2 scores smaller than 8 and 2 scores larger than 8. Point to note: the mean is the most representative measure of measures of central tendency, as its calculation involves all numbers or observations, as opposed to mode and median, in which only one or few numbers are involved. Measures of dispersion. Measures of dispersion are methods of quantifying how much scores differ from the mean. That is, they indicate the extent to which scores are spread out from the mean. Measures of dispersion are also called measures of variability or measures of spread. The commonly used measures of dispersion are range, semi-interquartile range, average deviation, variance, and standard deviation. Measures of dispersion. Okay, measures of dispersion is continued here. Let us consider the calculation of the range, variance, and the standard deviation of ungrouped data as an example. You are given the data for scores of 10 students, math tests, 70, 60, etc. as you can see. You are told to calculate the range, variance, and standard deviation. The range. We start with the range. The range is a measure of the distance between the highest and the lowest score in the distribution. Range of ungrouped data is obtained by calculating the difference between the highest score and the lowest score. Mathematically, it is given by the formula R is equal to H minus L, where R is the range and H is the highest score, while L is the lowest score. As a first step, identify the highest score and the lowest score from the given data. In case of our data, the highest is 70 and the lowest is 42. Formula for the range, as you have seen just now, is R is equal to H minus L. So we take 70 minus 42, which is equal to 28. Therefore, the range for the sample of data of the given data is 28. Note a point: rearranging the data in ascending or descending order first is useful because it minimizes error. Variance. Variance is the measure of variability which is obtained by squaring the deviation scores to produce positive numbers. Mathematically, it is calculated by taking the sum of the squared deviations divided by the number of observations minus 1. With the ungrouped data, the following formula is used. As you can see, the variance is represented by S squared is equal to summation of x minus mean squared over n minus 1. As you can see, x minus mean, it means the deviations of the score from the mean. Variance. Okay, we can calculate the variance using the example given here for ungrouped data. Calculation of variance. To calculate the variance is our first step. We have to calculate the mean. For example, in this data which we have been given, we have 8, 1, and 3. So we find the mean of these three numbers first. So 8 plus 1 plus 3 over 3 is equal to 4. The formula for variance is equal to summation of x minus x bar, which is our mean, squared, over n minus 1. So going back to our table here, we have to find, as our second step, we have, after getting the mean, we have to find the deviation from the mean for each score. So we take 8 minus 4, we have 4. 1 minus 4, we have minus 3. And 3 minus 4, we have minus 1. We square these deviations in the next column. So 4 squared is equal to 16, minus 3 squared is equal to 9, minus 1 squared is equal to 1. We find the summation of the deviations from the mean for these three scores. So we have 16 plus 9 plus 1, which is equal to 26. After that, we substitute these numbers in our formula. So we take variance is equal to 26 over 4 minus 1, which is 26 over 3, which roughly is 8.7. So here we have our variance. It means that how these scores variate from the mean. Now, after getting the variance, it is very easy to get the standard deviation. We said also standard deviation is one of measures of disparity. So once you have already obtained your variance, it is easy to get the standard deviation. Standard deviation is equal to positive square root of the variance. Now our variance is 8.7. So our variance will be 2.9. This will be our standard deviation. So one can ask himself or herself, why? Why all this business? What does standard deviation say? Or what does variance say? After obtaining the variance and the standard deviation, one can be able to interpret this data. For example, here we see that the variance is very small. It is not even, for example, the variance is 8.7 and the standard deviation is 2.9. Therefore, in this class, you see that the standard deviation is not there. From the numbers which you see there, you will be able to interpret that there is some variations in the scores of the students, but the variations is not so much. It means the one has 8, the other one is 1, the other one has 3. So then we can be able to interpret this. Okay, thank you, class. So far we have discussed about the measures of central attendance and measures of dispersion. If you examine them carefully, we need for ungrouped data. Now we are going to do one example to show some of the measures of central attendance and some of the measures of variability when we use the grouped data. If you remember, we said we have grouped and ungrouped data. Now we have an example on board where we have been given the data in a grouped data. We have these marks for, let's say, for geography form 3. Those students who obtained 20 to 29 are 4, 30 to 39, 3, 40 to 49, 5, 50 to 59, 12, 60 to 69, 9, 70 to 79, 7. Now we have been given this data. We computed the mean using ungrouped data, where we say the mean is equal to summation of all the x-scores, summation of all the x-scores divided by the number of observations, summation of x over n. Now, when we do now in the grouped data, you will see that we are not going to use this formula. Rather, we are going to use this formula. Summation of the frequency minus x minus the summation of the frequency times the max observation divided by n. As you can see, we have got class, intervals, and we don't have a specific number which stands alone as its x. So for calculation in the grouped data, we find the midpoint. That midpoint is the one which will be used as the marks obtained by the individual student. Now we are going to take, for example, how do we get the midpoint? The midpoint is obtained by, here we have fx. The midpoint is obtained by taking the lower class interval plus the higher class interval divided by 2. We get the average of the 2. Now, for example, in the first case, we have 20 plus 29, 20 plus 29 divided by 2. We have 49 divided by 2. So the x will be 24.5. This is how the class intervals are obtained. Again, in this case, we take 30 plus 39 divided by 2, we have 34.5. 40 plus 49 divided by 2, we have 44.5. Up to the end where we have 70 plus 79 divided by 2, we have 74.5. So as we have seen our formula, summation of the frequency times x. So the midpoint, it is the one which is taken as the x. So we have 4 times 24.5, we have 98. 3 times 34.5, we have this one. 5 times this, we have this one. 12 times 54.5, we have 654. Until we come here to the end where we have 74.5 times 7, we have 521.6. Getting the summation of all these fx, we have 2180. So this is the summation of fx. Summation of fx. Summation of fx. It is 2180. But again, we have something else. We have to find the sum of the frequencies. Actually, the sum of the frequencies is our n. It is our number for the observation we have been given. So we take 4 plus 3 plus 5 plus 12 plus 9 plus 7 is equal to 40. So summation of f is equal to 40. And the summation of f actually is our n, the number of observation. Now, substituting the values which we have obtained to get the mean, we have the summation of fx over n, which is equal to 2180 over 40. We get 54.5. This is our mean, our x bar. This is x bar, the mean. Having found the mean, then we start to find, we can move to another step. We can say, let us find the variance. You can be asked to find the variance or to find the standard deviation from this data. We are going to find both of them, the variance and the standard deviation. The formula for variance which is connoted by s squared, is equal to summation of f into x minus x bar squared over n minus 1. So we substitute these values. Now, before substituting, we continue finding these values. So we find the deviation from the mean for each mark. How does this mark here deviate from the mean? We have those who have obtained 20 to 29 who are 4. We have said our x will be the midpoint. Our midpoint is this one. So we say, how does this one deviate from the mean? Our mean is 54.5. So 54.5 minus 24.5, we have minus 30. Again, we have 34.5 minus 54.5, we have minus 20. We get 44.5 minus 54.5, we have minus 10. And here we have 54.5 minus 54.5, we have 0. So we have our 0 here. Again, 54.5 minus 64.5 minus 54.5, we have positive 10. 74.5 minus 54.5, we have positive 20. So this is the deviation from the mean. Again, we know that these deviations from the mean have to be squared because of removing the possibility of ending up with zeros. So 30 squared, 900, 20 squared, 400, 10 squared, 100, 0 squared, 0, 10 squared, 100, 20 squared, 400. So here we have already obtained our deviations from the mean, and also we have already squared those things. But remember, we have several students getting a particular mark. Here we have, for the mark 24.5, we had frequency of 4. 34.5, we had a frequency of 3. So every time we have to multiply these squared deviations by the frequency. So we have frequency times x minus x bar squared. For this one, we have 900 times 4, we have 3006. 400 times 3, we have 1,200. Again, we have this 100, 5 of them have obtained, we have 500. Here we have 9 students getting this mark. So 9 times 100, we have 900. Here we have 400, our square deviation, times 7 students, we have 2,800. So we get the summation of the f into x minus x bar squared. Our summation is 9,000. So we have our data. Having our data clear, now we substitute this data which we are having into the formula. So we have, for the variance now, we have for the variance s squared, we take the summation of x, fx minus x bar squared, divided by n minus 1. This value here is 9,000. So we have 9,000. Our n is 40. Our formula says n minus 1. So we have 40 minus 1. So we have 9,000 divided by 39. Our answer is 230.8. So this is our variance. Now, if we are told to find the standard deviation, we have 2 formulas for standard deviation. To find the standard deviation, we have to find the summation of f x minus x bar squared divided by n minus 1 square root of that. So we have the 9,000 here divided by 40 minus 1, which is 39, if you look at it closely, you will find that actually standard deviation is the positive square root of variance. As you can see, this is the formula for variance. Now when you put your under root here, that is when you get your standard deviation. So our standard deviation is the positive square root of variance. We substitute the variance which we have already obtained here in the formula. The square root for 230.8 is equal to 15.19. So we have our standard deviation as 15.19. So by using this example, as you can see, we have been able to calculate the mean, the variance, and the standard deviation. So this is how we calculate the mean, the variance, and the standard deviation for grouped data. As you can see, there are some differences as we saw the calculations for ungrouped data. So as we have seen, the statistics deals with data, and after computing various statistics, and also we saw the definition for a statistic. Mean stands for a statistic, variance is also a statistic, standard deviation is also a statistic. So coming back here, we are finalizing on the calculations of variance statistics using the grouped data. Thank you very much for listening.